Okay, so we have an example, no? Paano ginagamit ito. No? So we have here, again, I'm using the same example. Katong gikuhaan nato ng column. Load moments and shears, no? In the beam along column line B. So kini nga beam ang atong kukuhaan, no? Sa kini siya nga beam. Kukuhanin nato siya og moments and shear, no? Kung kinato i-design kini nga beam, then we need to determine first the moments and shear, no? So kini lang, no? Atong consideration kini siya. Ilang iyang moment diri, ilang moment diri, ilang moment diri. So actually, may determinate nga moment is not a moment diri, no? Negative moment. We have okay, sama na itong target. Okay, so ayan. So last time. Okay, stop ko muna ako presentation. So our beams are 560 by 520. While ang atong floor, no, ang atong kinahanglan information is actually the weight of the floor, which is 4 kPa. No? So ito yung kailangan natin. Okay, so then we are using normal weight concrete nga 24 kilonewton per cubic meter. No? So we are to determine the factor bending moments and shear forces in the beam along column B. So take note, kini lang atong kina-consider. Okay, sige. So let's start with our solution. No? Okay. So, usually pag ganito, no, pag simple lang, no, we can expect that the dead loads and live loads is uniform all throughout the span. Uniform talaga ni siya, no. So the tributary width, no, is supported by the beams along line B. Okay? Equal to 1/2, no, of the transverse span in either side of the column. No? So 1/2. So dire 1/2 ani and 1/2 ani, no. So in other words, there is atong slide, no. Ang atong tributary area is let's say shape. Ang tributary area ni mo ingon no. Let's say transparent na ta. Ito yung tributary area nimo. So this side here, 7,600 divided by 2. There, this is 6,700 divided by 2. So ang tibok ani nga length would be 7,600 divided by 2 plus 6,700 divided by 2. No? So that would be our, so 1/2 ani dire, then 1/2 dire. So let's compute, no? Ang atong first method is we have to calculate the tributary area. No? So calculate kita sa tributary area. No? Calculate so inside of tributary area, usually pag beam, tributary width lang. No? So tributary width. So again, 1/2 ani is 7,600 or 7.6 meter. Then this one is 6.7. No? So, okay, 1/2 ani. Then 1/2 ani. So 7,600 divided by 2 plus 6,700 divided by 2. Or that would be, let's say, tributary width. Let's say I'm using WT for my tributary width. So that would be, no? Ang first pa natin, 7,600 or 7.6 meters. And plus 6,700 will be 6.7 meters. No? Tapos, i-divide na natin sila tanan by 2. Oh, by 2, then that would be, okay, we have 7.15 meters. Okay. So we have already determined the tributary width. So the next step, we can now calculate the dead load. No? So calculate the dead loads. Okay. Dead loads. No? Okay, so first, consider natin ang atong weight of joist. No? Okay, so let's say na lang W, let's say joist. This is actually including na yung so let's say weight of floor na lang, floor system. Okay, that's combination of your the combination of your joist as well as your slab, no? That will be equivalent to the weight of the floor. So in combination now, joist, the weight of the joist as well as the slab, that would be the weight of floor, 4 kPa multiplied by the tributary width, no? 7.15, no? WP. That will give us the weight of the floor system in terms of kilonewton per meter. So per meter length. No? Usually pag beam, we express that one in per meter length. So i-convert ko lang niya to kilonewton per meter. No? We have. Okay, so we have 28.6, no? Para sa atong weight of the floor system in kilonewton per meter. Next. So floor system na lang ni. Floor system, let's say floor system, no? It consists of joist and slab. Next, we have the beams, no? Beam pa. Okay. So pag beams, again, we're not given with the weight of the floor, but instead, we're given with the dimension, and we know that our beam is using a unit weight of 24 kilonewton per cubic meter. So to determine the weight of the beam, no, let's say W beam na lang. That would be the unit weight of concrete, 24 per cubic meter, no, multiplied by the dimension, which is B times H. No? The cross section B. And then para parehas the rate kilonewton per meter, no, we have to convert this to kilonewton per meter. No? So we have 6.988 kilonewton per meter. Okay. Aside from this, now take note na siya is super, we have stations. Mga floor finish diha, kung na tiles, no, so we have to anticipate that one. So, ito, superimposed dead load. Then, ang iyang kuanan niya, ang iyang pressure sa superimposed dead load is tawag na itong PDL, pressure and superimposed dead load, that is 0.5 kPa. 0.5, ay, nawala nga ako ng black. 0.5 kPa. Okay, so, tawag na natin din nga W SDL, no? Superimposed dead load. That would be equivalent to ang pressure para sa superimposed dead load in kilopascal times the tributary width, no? Okay? And then in kilonewton per meter para consistent sila tanan. Okay? So we have now the superimposed dead load in kilonewton per meter. So therefore we can compute the total dead load, no? Total dead load, no? Usually ang dead load is WDL na lang. WDL. That would be equivalent to, okay, ang atong weight of floor system, and plus sa atong weight sa beam, and plus sa atong weight sa superimposed dead load, no? So that means, equivalent siya sa 28.6 plus 6.998, then plus 3.57. So, magawas na lang na direct. Okay, so we have the value. So, hibong ko lang yung kilonewton per meter. Okay, so for our dead load, ang atong total dead load is 39.1638 kilonewton per meter. Okay? So, next, compute kita sa atong live load. No? Kung na sa dead load, no? We're done with the dead load. Then, live load na ta. No? So, anong kinanglan natin magbutang og live load? Siyempre, para makomputa natin og WU, no? Which is a requirement later on. Okay, so this, since it's a floor, no? Floor ni siya, no? And we have to apply, typical floor ni siya, we have to apply the live load reduction, no? So, So, reduce live load. Okay? Or apply live load reduction. Okay, so for floors, ang formula ginagamit natin is ang nasa atong slide, which is equivalent to L. We have L sub O, the nominal live load found in the code. So we'll be using the metric na formula, 4.57 divided by the square root of KLL times the tributary area. Okay. Now, according sa code, no, kung sa atong previous example, ang atong value sa atong KLL is 4. No? Ang atong KLL, we're using 4 sa atong KLL. No? This time, no, kay di man siya, the value would be KLL is equals to 2. Okay? So, that's the value for beams. No? Ito ang value. Next, calculate natin ang by the way, this one, no? So, for office use, no, based sa atong previous example, pag office, this is equivalent to 2.9 kPa. Okay, this is found in the code. So, 2.9. So, this is office use. Okay, so this is coming from NSCP 2015. So, ikuha niya siya from the code, no? 2.9. Okay, next, we need to compute our A sub T. So, dapat wala siya unit, no? So, again, since ang atong tributary width, no? So, let's go back here. Ang atong tributary width is 7.15. And then, considering lang, ating consider, kininaw sa span, no? Pareho sa mga dire. Okay, so, that would be, okay. Kini nga length, which is 7.15 times this length nga 6.1. That would give us the tributary area. So, for sa beam, for one beam, inuna ning imong tributary area. So, width times the height. So, this one is 7.15 ang total ani times 6.1. Ito dere. A sub T is equivalent to ang atong tributary width, no? Which is equivalent to this one. So, di kita magamit ang WT because na siya unit. No? So, ang atong formula, wala unit. So, ang value na lang, which is pila to dire, 7.15. 7.15 times 6.1. So, aboy natin ng unit para unit ang formula natin yung the answer. Okay, so compute na. Okay, we have Pascal and then let's make it in kilopascal. We have 2.144, no? But then there is consideration gapon sa atong code nga this one is supporting kung nagsusupport siya og 2 floors 0.4 and if supporting 1 floor 0.5. So okay, so let's call this one as L1 na lang, no? And we have to compare that one with L2. Kung supporting one floor, di ba natin condition ang atong code nga 50%, no? We have 0.5 times L sub O. Okay? PPA, di ba? This is supporting one floor, no? Tapos, ibaningon ko siya nga whichever is smaller. Okay? Whichever is whichever is larger ani nila. Okay? So, this would be W, no? So, let's refer to the code, no? Kalimot ko sa atong code, no? I will be referring to the code. Say value ani. Okay, so, open muna ako ng NSCP. So, I forget the code exactly. Ano ba yun? Let's go to the code. NSCP. Okay, so, may kasi sa amin, ano ba talaga to? Okay, yan. Okay, so this one. Okay, so we have here the code. Then, asa to ka provision. Adi, no? 40. Okay, this one. No? The reduced live load shall not be less than 50% of the unit live load for members receiving load from one level only. So shall not be less than 50%, no? Nor less than 40%. So in other words, no, whichever is larger. So dapat hindi siya less than by 50%. No? So this one, since larger siya ani, then we'll be using L1 as our L. Okay? So this would be the reduced live load. Or you can use the program ani, no? Let's say, ang atong reduced live load is equivalent to, you can use the program na lang, no? Using this command. So, if L1 is less than L2, okay, whichever is larger, no? Then, L, no? Is equals to L2. Else, L is equals to L1. Since ang atong L1 is greater than L2, and ang atong L magawas diri would be, ayan, 2.144. Okay, so this would be our reduced live load, no? So, mali nga. Okay. Of course, we need to include also the partition load, no? Movable partition, okay? We cannot really, usually pag offices siya, natay mga cubicle, diba? Nagbutan kita mga cubicle, but they are not permanent, they are movable. So we have to include movable partition. Usually, ang ginagamit ana niya, according sa code, 1 kPa siya. No? According to the code, pag movable partition, we have to use a value of 1 kPa. So therefore, ang atong live load now would be, okay, so ang atong reduced live load, okay, so the reduced live load natin, plus 1 kPa nga, movable partition, then you have to multiply that with the tributary width. Okay? You have now the live load in kilonewton per 5. Kilonewton per meter. Okay, so we have now the live load and we also have the dead load. So muna yung mga importante nga value natin nga we will be using later on. Okay. So next, okay, see, having determined now the dead load and the live load, no? So na-determine na natin. The next step is we are going to verify whether we can apply pwede ba natin i-apply ang simplified methods, no? Kung pwede ba, no? That would be our... So taas siya, no? As you can see, wala pa ito nagsugod. Nag-compute pa lang ta sa dead and live load, no? So nag-compute pa sa pilang dead load, nag-compute pa lang ta pila ang live load. So after nakuha natin ang dead and live load, then we are going to verify kung pwede ba siya magamitan og pwede ba siya mga katong simplified method, no? So we have to check, no? Let's say check if the simplified method can be used, no? So sa itong number 1, no? Number 1 requirement natin is, diba, based sa itong slide dere, members are prismatic. They have uniform cross section. So rectangular man, no, ang atong beams is constant, then pwede, no? Beam have constant cross section, no? So okay siya over the entire length. Actually, no, kaya ang atong beam, ang iyang length ani is kini siya 560 by 520. So kanan nga beam niya is 560 by 520, so constant. Number 2, so ang atong load is uniform distributed, no? Rectangular, no? So okay siya gahapon. So number 2, okay. Ang atong loads are uniformly distributed. Rectangular load ni siya. Okay, one-way slab. Pag two-way, trapezoidal siya, but this one is one-way slab, then loads are uniformly distributed. Then number 3, so another, mo siyang reason nga na nag-compute gihapon ta. Ibang number 3 nga requirement is the unfactored service live load, no, does not exceed 3 times the unfactored service dead load. So, anong reason, no? So, compute ka, no? Unfactored live load, LL, no? Does not exceed 3 times the unfactored dead load, DL, no? At ang atong since i-express natin in terms of uniform distributed, then we have WLL divided by WDL, no? So, i-compute na natin siya, no? Kung at WLL, 22.5, then ang atong WDL, we have 39.17, no? So, compute natin. Okay. Okay, this is less than 3. So, does not exceed. So, okay siya, no? So, less than 3. Okay, so, qualified, no? We can use the condition na meet natin. So, okay, there are 2 spans, no? Duhaman ka span siya, no? Natay span 1, span 2, 2 spans in the y direction. Kaya mo net column B. So, kini ato consider diling padulong dito. Kung padulong samot dito, kung padulong kadaghan ng span. So, there we have 2 spans, no? Between 1 and 2 and 2 and 3. So, 2 spans. Okay siya. Okay, so number 4. Okay. There are 2 spans. Okay, so na-meet niya condition. So, ang last na lang, spans are equal, no? Diba, dere? Spans are approximately equal. Equal lang natin. Kaya ang atong 2 span, ang iyang length having tag 6.1, 6.1 meter. So, okay siya. So, in example, we can use the spans are equal, no? Tag 6.1, okay na. So, all are met, no? So, tanan. Okay, so because of this, no, the simplified methods can be used, no? So, pag-reason mo, because all 5 conditions, so kung narayo sa diri nga wala na meet, then diri na pwede gamiton ang simplified method. So, this one, satisfied tanan, are satisfied. Then we can use the simplified method, no? Can be used. Pwede siya gamitin, no? Okay, so ang areta sa atong ano, di ba? Kini na. No, sa natay dire WU. Unsa man yung WU? Kini. Mo siya ang load combination, factored load na ni siya, no? So, calculate factored load na ta. Okay? Ang WU, since natay last time, no, atong first mapping, i-state natin nga for live load, we're using 1.2. Natay table dito sa atong first slide. While for the live load, we're using 1.6. No? So, explain po natin nga nung si dead load, gamay siya factor kumpara sa live loads because also we are using a larger value. Okay, so we have now the value. Okay. Ayan. Okay, so natin WU. Next step natin dito sa formula natin is natay kining L sub N, no? Kining is the clear span, no? Clear span. Okay? So for two span condition, no? That should, in our case, since parehos ng atong ano, parehos ang atong kung maglahi ang iyang value, for example, this one, lahi ang imong ano, lahi ang imong first, lahi ang value sa imong LN1, sa imong LN2, then we will be using the average. But ang atong pareho 6.1 by 6.1, then 6.1 ko siya, minus na lang the column, no? Minus na atong column. Ang atong column, by the way, is kwanto siya ang atong column? 560 by 560. No? If you can remember, ang atong column is 560 by 560. Okay daw. Ako rivet file. I'll be opening Revit. No? So, using the same, ano. Project 1. Okay, so we have here na, no? Ito yan. So, ang atong column is, ito itong dimension ni, okay, 600 by 600 pala, no? So, this is 600 by 600. So, ang clear space niya, no? Kumano niya ito, no? So, ang clear niya is this one. Okay, that is, ano, ayun, ito yun, that's LN, no? Or pwede po natin i-compute na lang. So, pwede compute or you can, kung naka-Revit, no? You can measure it directly from the, no? You measure mo is 5,500 or pwede natin na siya i-compute, no? So, compute na lang natin. Kung wala kaya na, then pwede natin i-compute. To do that, simply, minusan lang natin ng kuwan, no? Pwede natin siya minusan of the column dimension, which is 600 pala, no? So, calculate the, let's calculate that. Calculate clear span. So, to calculate that one, so, ang atong center-to-center spacing, no? LN equals to 6.1 meter, no? Minus the column, 600 mm. Okay, you have 5,000 or 5.5 meters. So, ano siya, no? You have here 5.5. Okay, so, yun gagamitin natin. Okay na? So, once we have determined now, then, okay na ta. We need compute. So, sa atong dire, natay, ano, kuya ito na siya section siya. No? Determine na itong section. To the section. Okay, tapos, okay. So, pag binuot yung section na ako, I will do the sections. Section 1, ito yung makikita ko. No? Okay, so this is the section. Okay, so nagka-consider ko la, okay, this one. No? So, pwede niya okay, so pataas mo kaya pa yun. Loading up computer. Okay na. So, then, isolate ko lang so that kinilangan po ng level lang ako i-consider. Okay, so ano siya. No? Then, siguro, let's go back here para, ano, section, wala yung section view po. What happened to my section view? Level 2. Okay, so wala. Nawala ako section view. Okay. Okay, so pwede. Okay, dito na yun. Dito mo yung section view na ako. Nawala. Delete mo na. Okay. Kahit ko na doon section, nawala ako section view. And para wala tong bin makita. Oh. Okay, mumove ko ni siya by this. And let's have the section views. Okay. Para much better. Let's say for a typical floor, no? Okay. Mamaya ito kinanglan, no? Okay. Okay, so kung yung tubutangan o dimension. Okay. We have, no? Ayan. So, ato i-consider, consider natin, no? Typical floor. Okay? So, dire, no? Based sa itong slide natin. Okay? So, we have to identify, no? Ano ba ito dire, no? Pila ba ang moment dire? Okay? So, identify natin ano saan na siya. So, based dire sa itong characteristic. Okay? So, ano ba nga gamitin natin, no? Okay? So, dire, no? At integral support, no? Based on this. Ano ba ito, no? So, this one is actually integral na siya with the beams, no? Moderific na siya. So, therefore, ang atong gamiton dire nga moment, no? At this point, we'll be using this one. Column support para dire, no? Okay? So, let's say, muna dire, no? So, in other words, the moment here would be, okay, kuya ito butangan ng gano'n. Ang atong value dire would be WLN squared, no? Let's say muna ito dire nga moment, let's say MA na lang ni siya, no? Let's call this one as MA. Okay. Okay, this one is MA. MA. No? The problem is wala siya mali siya subscript pala. Call that one as MA. Okay. By the way, puya tubutang description. This is, wala na description na lang. Another description. This is actually the integral, no? This is the integral based on this, mo siya, no? Integral with support, no? Ano siya? Or let's just place na lang the value, no? The value is equivalent to W U, then that would be LN, then next natin. Okay? Then, ay, wala siya i-divide pala, no? So, WU L N tapos squared, no? And underline na lang natin siya or pwede siya. Pwede. Divide by 16. Okay? So, ano ba yun dire, no? Okay, so, ayan. Identify natin which value to use. Ito maglisod. Okay. What about dire sa ito nga at mid-span, no? At mid-span, based on this, no? That is WLN, no? Squared over 14, no? Dili kini siya dapat naa pa sa duha ka extra mid-span. Napay duha ka span, but this time duha ra man siya ka span, then we'll be using the WLN squared over 14. No? So dire. So kapihon na lang naton para sa mid-span naton. Then this is equivalent to 14, no? Balik. Okay. Okay. Kini kapihon ko na liwat, no? Copy. There, and this is, let's say, B. And kini, pwede kapihon ko na lang sad. Let's say I'll call this one as B. Okay. Apply value dire, no? Okay. So therefore, the value dire, no? Tanaw natin dire, no? What would be the value? Okay. So, ano bang value natin? Okay, so this is actually based on that, no? This is the integral face, no? For the exterior face, no? The exterior face of the first interior support, no? So therefore, no, beginning, no? This is the value. Okay? Okay, pwede po ka mo gamit og note, no? But then, kailan nato gamiton, no? Let's say. Okay. Parang kulang ini. 2 or more span. 14, sakto ng 16. So, this one is for, kung span drill, but kung wala, so, yan, yeah. For 2 span condition, first interior negative moment, ito, no? Can you see, this is for span drill. But kung di siya span drill, since di naman span drill, integral support naman, then we'll be using this one. W ln squared over 9. So, kulang man, wala din rin. Yan, so that would be the value. So, okay, no? So, this value, no, ang atong gagamitan. Okay. So, ito nga value. Using na ito. Okay, so let's go back to our rivet. Okay, so, sabihan ko na rin eh. And then, i-edit na natin. Okay. And this is equivalent to, again, 9. So, okay. Ito para sa share. Okay. So, tayo share. Ang next na lang natin is para sa moment. No? We're done with the moment. Next na lang. So, atin, parehas lang diri. Whatever ang nadiri, since symmetrical man siya, the value would be the same. No? So, parehas lang nadiri. Okay, so mirror lang. Whatever ang value diri would be the same on the sides. Kaya lang, gini siya. So, mirror lang. I-mirror lang natin value. Okay, so let's go to the share. Okay, so ang share na to, again, is okay, what will be the share? So, kani, no? So, this would be the share natin. Okay, so for this one, we have W ln over 2. Okay? So, mahirap ba yun rin? Okay. Go back. Our share, no? So, again, ihan ko na rin eh. Let's go with share. So, pwede pa natin i-drag po, boss, para medyo to give more space. Ayan lang, pangit. Okay, so the value is, pwede akong kapihon na lang eh. Okay, and then, i-edit ko na lahat. This is equivalent to W. F is over 2. Then, wala tayo share sa, wala tayo share sa center since usually, ang moment ani, ang moment ani usually, pag nilihim mo tag-share diagram, if you consider remember, kung nakailog niya yung unani, uniform distributed, ang share diagram, unani. So, 0 ang atong share, Natin share doon sa A, share sa B. Usually, ang atong share there is 0. So, therefore, wala tayo share sa ito nga. Ang naalang natin sa end. So, kini ang sa first end, then ang second end dire. So, this would be 1.15 W ln over 2. Dari. Let's say. Ati ko lang ni. Let's say share at B. Then the value would be, pwede ko lang kopyahan. Kaya ni-edit ko na lang. Equivalent to 1.15 W ln over 2. Okay na. Okay. So, natay values, So, therefore, pwede tayo mag-solve. Okay na. No? Ayan. So we have now the values. Pwede na. Pwede natin butang sa taas na lang ni para medyo ano, much better yung kanapos. Ay, yung center man ako na ano. Center to center, then of course, pwede po taog. So that's then. Okay, so kuya natin ibutang dito sa atong ano. Ini kuya natin i-hide na lang natin ni. Ayan, magmuha. Okay, so ako na lang na siya okay, or other. Point hindi natin consider. Okay, ayan, we have now. So, replace na natin dito. Okay, so we have now the... Okay, so from that, we can now calculate the corresponding values. So, easy na. Okay, so here, MA na lang. So from here, we have your MA, that's equivalent to WU times LN squared, divided by 16. Divided by 16. Okay, so convert ko lang to kilonewton per meter. We have now the moment sa atong MA. Okay, then gusto na to midspan, let's say MAB, Then ang atong midspan is WU times LN, that would be a squared hapon, but this time divided by 14. Ayan. Okay, so we have your MAB. Then finally, karipod sa MB. Our MB is WU times LN and this is divided by 9. Okay, so compute na lang siya. Okay. And finally, share at A. Wala na. So, much better siguro. Saka ko ni gamay. Marami dyan. Marang siya. Okay, so yan. So, this is A. Okay, based atong formula, WU and LN divided by 2. Ayan. Pwede yung the whole na lang. Pagkapareho sa kapag answer. Okay, so have it in kilonewton. Then, dealing aside, we have 1.15 times WU times LN divided by 2. Okay, and kilonewton. Okay, so these are the answers, So you will be using this one pag maning values ang atong ginagamit, to determine ma-determine ang mga moments, Ayan. So maning mga tinang natin gamiton. Okay. So maning ginagamit pag design na. Mario lang share. Okay na. So, we have now the values. Okay. Ayan. So, we have now the answer, So, ano siya, Okay. Let's say na like example 2 siya. Let's say, sheet 2. So, okay. Ayan, So, we have determine na, Okay. That's how. So, ano ginagamit ng pag-design, So, dire, ma-design natong reinforcement. Kung pila kakabili ay butang nato dire. Karipod, pila kabilya magamit natin diri nga end. Sa center, pila kabilya magamit. Then, pila ka stirrups. So, information needed prior to design, no? So, yan. So, kaning ato gi-discuss karon is pag-determine pa lang sa input for your design. Actually, kining mga moments, these are your input sa